Hello, and welcome to your first pre-party for Food Science 1410, Food and Our Well-Being. I'm going to start by explaining what a pre-party is, because you're probably not familiar with this term. I have stolen the term from Rachel Watson, who's kind of introduced me to the concept of using pre-parties to prepare students for in-class activities. So my pre-parties will typically be a video that you will be asked to watch before you come to class. Once you watch this video, you'll have the foundational knowledge to allow you to excel or succeed at the activities we do in class. The videos will range anywhere from 5 to 30 minutes, just depending on the content that we need to prepare ourselves. Sometimes it may not be a video for the pre-party. I may ask you to read a research article, or I may ask you to monitor a certain aspect of your daily lives and relate it back to food. But for the most part, it'll be a video just like this. If you have more questions about the pre-party, I'm more than willing to answer them. Please come see me before class. We can talk one-on-one, or raise your hand when we're with the group and we can answer it so everyone's on the same page. Now we're going to start with our first topic of the semester, human digestive anatomy. For some of you, you've had the chance to learn about the digestive tract, so this will be a review. For others, this may be an introduction to the digestive tract and your own anatomy. And so let's go ahead and start by just understanding some general premises. First, we have to ask ourselves, what does the digestive system do? Remember, I'm going to keep it pretty broad. That way we can start to investigate more and more as we work through class in the next couple of days. So when we say digestive tract, the number one thing that it's going to do is digest food. And by digest food, I mean taking larger pieces and breaking them down into smaller particles. That way, our digestive system and our body can utilize these smaller particles for further functions. We can understand this by thinking about the bite size that we eat. Imagine yourself eating a big, juicy cheeseburger and following it up with a handful of fries. I will tell you, Freddy's is my favorite burger joint, so that image is coming to mind as I sit here and talk to you about the digestive system. I can monitor or manage the bite size that I take of that Freddy's cheeseburger. If I'm really, really hungry and I haven't eaten all day, I'm probably going to eat a pretty large bite. If I'm not that hungry, or I remember what my grandma told me and always eat smaller bites, I'm going to take smaller and smaller pieces from my hamburger. So we can see the bite size that we put into our mouth every time we eat. And that bite size will get smaller and smaller as the food travels down the digestive tract into the stomach through the intestines. So the system involved in digestion allows processes, mechanical and chemical, to break down food to smaller and smaller pieces. Straightforward, right? Well, once we get those smaller pieces, we have to do something with them. And our body prefers to absorb nutrients to allow it to function. These nutrients that come in our food, carbohydrates, proteins, fats, vitamins, minerals, those are not necessarily available in that bite that I took of that Freddy's cheeseburger. Instead, my body has to break down or digest that bite into smaller pieces to allow those nutrients to become more available and then be absorbed into our system. Absorption typically takes place in the small intestine, but if we only had a small intestine, we would be unsuccessful digesters of our food. So digestion and absorption of nutrients is a pretty known fact of what our digestive system does. There's one other thing that's very, very important that oftentimes gets missed. Our digestive system acts as a physical barrier to the entry of microorganisms in our body. If we think about it, our body only has two openings, the mouth and the anus. Beyond that, it is a closed system. So anything that we consume should enter and exit through those openings. However, through the absorptive process, things can get through. Our digestive system is that physical barrier to say, oh, you're a bad thing, you're a bad bacteria, you're not allowed in. Or they can say, oh, you're a good thing, you're a nutrient that my body needs and can allow it in. Beyond being just a physical barrier, our digestive system also houses its own microorganisms. These microorganisms are mainly in the large intestine, and they help us regulate the bacterial life inside of ourselves. We want good bacteria to allow us to digest and absorb nutrients. But if we are exposed to a pathogen or a harmful bacteria, say because we didn't quite cook a hamburger at home to the temperature that we needed, our own microbiota or our own microorganisms will help modulate and prevent us from getting sick. That's not to say our digestive system is the only immune process to keep us from getting sick. It's just one of many things that helps us in maintaining the integrity or our health. So now that we know what the digestive system does, let's talk about, in general terms, what makes up the digestive system. First, the tract is anywhere from 15 to 25 feet long. That's a pretty big range, and the reason it's so big is because there are some discrepancies in the literature. There are some sources that say human GI tracts are closer to that 15-foot length. Others say it's close to that 4 to 7 meters and can get up to that 25-foot length. No matter what, it's dependent on the individual. So my GI tract might be longer than yours. My GI tract might be shorter than Donald Trump's. It's all dependent on the individual. Where we see differences in length typically comes from our intestines. The mouth, the esophagus, the stomach aren't going to add dramatic length differences. So that small and large intestine is where we see variability. And you're going to get a chance to get hands-on with a digestive tract, no, not a human's, but a pig's, and really measure length differences. So let's start with the mouth. The mouth is what we can actually see of our digestive tract. We put food in, we chew with our teeth, our tongues, and our cheek muscle. Once food leaves our mouth, we become less associated with it. The digestive system is an involuntary system, meaning our brain doesn't tell our stomach to mix and churn food and then to release food down into the intestine and our intestine to absorb. Our brain does that all on its own. Fortunately for us, that's a good thing, because I know I have way too much to think about in a day, and if I had to think about my digestion and absorption of nutrients, I'd have to slow down my lifestyle. Nonetheless, once food leaves the mouth, we see it goes into the esophagus. Sometimes, if you don't chew your food fully, you can feel that bolus going down your throat and into your stomach via the esophagus. For the most part, the esophagus is a very stable organ. There are some people who develop diseases of the esophagus, which can cause some irritable upset when it comes to eating. Once the food leaves the esophagus, it enters into the stomach. The stomach is essentially the mixing and churning organ of our GI tract. Without the stomach, we wouldn't allow that digestive process to start, namely the chemical digestive process. In the mouth, we are mechanically digesting food, breaking those pieces smaller and smaller. Once that food gets to the stomach, we can introduce chemical digestion through hormone release and start to get really intimate in terms of exposing those nutrients before they go into the small intestine. Sometimes the stomach, you can feel really, really full. That means the food you have eaten has filled the volume of your stomach. On an empty stomach, you can have very small organ. However, if you eat a lot, say you go to the China buffet downtown and eat yourself full, your stomach will expand and expand and expand and to reach that maximal capacity. Once food leaves the stomach, it enters in the small intestine. The small intestine is extremely important to that digestive system. Without the small intestine, we would not be able to absorb nutrients and utilize those nutrients to help us maintain weight or to grow if we're young children or maintain proper immune function. However, with a digestive tract that consisted of only the small intestine, we would not be able to get to those nutrients to be absorbed. So remember that digestive tract works as a whole, even though it's made up of many, many organs. The small intestine, remember, is where I said there was variability in length. Small intestine might be anywhere from 4 feet to 8 feet. Again, we're going to investigate that next week. Once the food travels through the small intestine, it goes into the large intestine. Wait, let me back up. I forgot. There are 3 kind of accessory organs to the small intestine. First is the liver. The liver produces bile, and bile allows us to absorb fats and lipids that we consume. That bile that is produced by the liver is stored in the gallbladder, so the two are very directly associated. Then we have the pancreas that is also associated with the small intestine. The pancreas produces enzymes that allow us to digest fats, proteins, and some carbohydrates. So the liver, pancreas, and gallbladder are accessory organs to the small intestine. Okay, now we can go back. The large intestine. The large intestine is the last organ within the GI tract. However, it does have 3 different parts. And if we look at this model, and I'm going to turn because my screen is off to the side, the large intestine is this larger diameter tube that runs kind of around the GI tract. The 3 parts are the colon, which runs all the way around. Then we have the rectum and the anus. We'll see in class that the colon has different parts itself, but the large intestine's goal is to absorb any water to keep us hydrated and to formulate feces for expulsion. So remember, that's a general description of each. In class, you guys are going to break into your teams and further investigate each of these organs in more detail. So I'm not going to give you all the information. I'm going to leave that suspense for class. So now a question a lot of people ask, I do myself, is how long does it take a meal to travel through the GI system? So if I were to go to Freddy's right now, eat a cheeseburger, fries, and definitely some ice cream because that's the best food in the world, how long would it take for that meal to travel from my mouth to the toilet? Well, there is no clear-cut answer. The answer is variable. The time it takes to travel from the mouth to the toilet varies depending on age, health status, and diet. Typically, older people, their digestive muscles weaken, leading to constipation. And with constipation comes a longer, more extended time for that food to travel through the entire system. Pregnant women typically secrete a hormone that leads to constipation, again extending the time. If we think about diets heavier or higher in fat cause for a longer digestive period. So if you are eating a low-fat diet, the length from mouth to toilet is shortened. We also think about status of an individual, overweight versus underweight. Overweight individuals typically have stomachs that carry more food for longer periods. So the stomach houses that food for a longer time before it's emptied into the small intestine. Then if we think about how frequently we eat a meal, if we eat more frequently, we can typically improve digestion because eating triggers movement of food from one organ of the system to the next. If we go extended time between meals, we have to reinvigorate that movement, causing for more length from mouth to toilet. And if we think about the order that we eat a food is not necessarily the same order that the food leaves an organ. Through all of the mixing and churning that happens in the stomach and the small intestine, food is mixed around so that ice cream I ate at the end of my meal at Freddy's may be the leader in terms of entering the large intestine as digestion goes on. So, if we think about it, it could be 2 days later that a meal is passed as feces. It can range, on average, anywhere from 24 to 60 hours. The limiting factor is typically almost always the time it takes for food to pass through the large intestine. The large intestine is kind of the holding tank, and it doesn't have a whole lot of movement except right around mealtime. So that large intestine time will oftentimes dictate the length or time it takes from mouth to toilet. But remember, 24 to 60 hours is really where you're at. We wouldn't probably want to wait that 60 hours before going to the bathroom. We're trying to use the restroom every single day. Anyway, I will see you in class on Friday, and we will start with an IRAT and a TRAT. So all of the information that you've just learned in the last 15 minutes will be fair game on the 5-question IRAT that you do yourself, and then the 5 same question TRAT that you do with your teams. We'll see you on Friday.